submodule under Safety in the course Health, Safety, Environment Protection or HSE. HSE consists of 4 main modules that will cover the above-mentioned aspects in detail. Click here to view the learning outcomes for Safety Management 1. Management, by definition, is the process of setting policy, organizing and controlling the workforce, monitoring and reviewing the efforts and outcomes of an organization, and the use of other organizational resources to achieve the stated goals. With regard to health and safety management, these goals will include protection of the people or employees as well as non-employees from harm, injury, or ill health. Compliance with applicable legal requirements to avoid prosecution and to demonstrate best practices. Providing cost-effective management of health and safety in harmony with other key business objectives. The performance of an organization, whether in terms of safety alone or more widely in terms of its business measures, is affected by a number of issues. Probably one of the most important aspects is the effectiveness of the management processes within the organization. However, even the best management processes can be defeated by the way in which people approach and undertake their daily tasks. On that note, let's explore the key to ensuring efficient safety management systems. Compliance by personnel is the key to efficient safety management systems. A safety management system that has addressed all risks by creating procedures and safe systems of work is little more than wasted effort if it is not carried out and complied with by the employees. In other words, human factors are the key to the efficient operation of an organization, and addressing the issues that affect human factors is most likely to gain great return for the effort expended on it. There are a number of health and safety management systems that exist around the world. These include ILO, or International Labour Organization, OSH, 2001 Guidelines on Occupational Safety and Health Management Systems, or ILO. OHSAS 18001, 2007 Occupational Health and Safety Assessment Series. BSI. HSG 65, 2003 Successful Health and Safety Management Systems, UK Health and Safety Executive. In this study, the focus will be on British Standard OHSAS 18001-2007. You'll explore this system shortly. Before we examine British Standard OHSAS 18001-2007, let's take a look at the value of management systems. A poorly planned management system that forces unreasonable demands on the workforce is more likely to promote a negative culture than a positive one. Where systems are complicated or difficult to carry out, especially where the workforce do not know the reasons for the complexity, they are most likely to fail through lack of compliance. Similarly, where the resources to carry out the tasks properly are unavailable, there is again a high likelihood of reduction in the safety culture. The lack of resources will diminish the workforce's perception of management commitment and will, either through frustration or a misguided attempt to complete the task, cause any positive safety culture in place to dissipate, thus rendering the safety management systems ineffective. Good management systems, both safety-related and general, are a main contributor to a positive safety culture, and a positive safety culture, in turn, reinforces good management systems. You have explored the significance of efficient safety management systems. Now, let's delve into British Standard OHSAS 18001-2007, a popular safety management system. The OHSAS 18001 standard is compatible with the ISO 9001-2008, that is, quality, and the ISO 14001-2004, that is, environmental management system standards, in order to facilitate the integration of quality, environmental and occupational health and safety management systems by organizations should they wish to do so. The OHSAS standards are intended to provide organizations with the elements of an effective OH&S management system that can be integrated with other management requirements and help organizations achieve OH&S and economic objectives. OHSAS 18001 specifies requirements for an OH&S management system to enable an organization to develop and implement policies and objectives which take into account the legal requirements and information about OH&S risks. It is intended to be applicable to all types and sizes of organizations and to accommodate diverse geographical, cultural, and social conditions. You've been introduced to British Standard OHSAS 18001-2007. Now, let's take a look at the aim of this safety management system and the PDCA process approach. The overall aim of the OHSAS 18001 standard is to support and promote good OH&S practices, including self-regulation, balanced with socio-economic needs. This standard can be used for certification by third-party agencies and/or self-declaration of an organization's OH&S management system. Demonstration of successful implementation of this OHSAS standard can be used by an organization to assure interested parties that an appropriate OH&S management system is in place. The OHSAS standard is based on the methodology known as Plan, Do, Check, Act, or PDCA. PDCA can be briefly described as follows. Plan. Establish the objectives and processes necessary to deliver results in accordance with the organization's OH&S policy. Do. Implement the processes. Check. Monitor and measure processes against OH&S policy, objectives, legal and other requirements and report the results. Act. Take actions to continually improve OH&S performance. You've explored the relevance of safety management systems in general and British Standard OHSAS 18001-2007 in particular. It's time to take a safe shot. Drag the options and drop them in a sequence as per the PDCA methodology. You've examined the aim of British Standard OHSAS 18001-2007 and explored the PDCA process approach. Now, let's explore its relevance to the OHSAS standard. This OHSAS standard contains requirements that can be objectively audited. However, it does not establish absolute requirements for OH&S performance beyond the commitments in the OH&S policy. To comply with applicable legal requirements and with other requirements to which the organization subscribes. To the prevention of injury and ill health. And to continual improvement. Thus, two organizations carrying out similar operations but having different OH&S performance can both conform to its requirements. Section 4 of the standard discusses the details of the individual elements of the occupational health and safety management system. They are as follows. General requirements, policy, planning, implementation, checking, review. You'll explore each of these elements in detail shortly. Here's an overview of the elements that comprise Section 4. Section 4. The elements. You've been introduced to British Standard 18001-2007. It's time to take a safe shot. Choose the correct options. Which of the following are subsections of Section 4.4, Implementation of OHSAS 18001-2007? You have explored OHSAS 18001. Now, let's examine ISO 14001. Both the above-mentioned standards are similar in many aspects. Both the standards follow the PDCA approach, and the sections are exactly the same in both cases, viz. Policy, planning, implementation, checking, and management review. Of course, there are subtle differences in different subsections. However, the most significant difference lies in Section 4.3.1, which is part of the planning section. In OHSAS 18001, Section 4.3.1 deals with risk assessment, and in 14001, it deals with environmental aspects. You'll take a detailed look at the latter shortly. Some of the important requirements of Section 4.3.1 of ISO 14001 are given below. Identification. The organization shall identify, based on a documented procedure, the environmental aspects that can be controlled and are within the influence of the organization of its activities, products, and services, taking into account any planned or new developments also. Categorization. The organization shall determine those aspects that have significant impact or impacts on the environment based on the same procedure. Documentation. Identified aspects and the significant impacts shall be documented and kept up to date. These significant environmental aspects shall be taken into account as a priority while establishing and maintaining its environmental management system. Recognition. While identifying environmental aspects, emissions to air, releases to water and land, use of raw material and natural resources, use of non-renewable energy, energy emitted, that is heat, radiation, vibration, etc., into the environment, and waste and byproducts shall be considered. Classification. Changes to the environment, either adverse or beneficial, that result wholly or partially from the environmental aspects are called environmental impacts. You have explored ISO 14001-2004. It's time to take a safe shot. Choose the correct option. In ISO 14001, Section 4.3.1 deals with risk assessment. You have explored two international standards, namely OHSAS 18001 and ISO 14001. Now, let's learn about Ilo Os 2001, a document issued by the ILO regarding the design of a health and safety management system. We will only take an overview of this since we have already discussed in details about a similar management system standard, OHSAS 18001. This tripartite approach suggested by ILO provides the strength, flexibility, and appropriate basis for the development of a sustainable safety culture in organizations. These voluntary and practical recommendations are intended for use by all those who are responsible for occupational health and safety management. These are not legally binding and are not intended to replace any national laws, regulations, or accepted standards. You've been introduced to the significance of Ilo Os 2001. Now, let's look at the guidelines of Section 2.1.1 in particular. As per Section 2.1.1 of Ilo Os 2001, a competent institution or institutions should be nominated as appropriate to formulate, implement, and periodically review a coherent national policy for the establishment and promotion of OSH management systems in organizations. This should be done in consultation with the most representative organizations of employers and workers and with other bodies as appropriate. As per the above mandate, the Government of India has come up with a national policy on this topic. You will explore the salient features of this national policy shortly. You have familiarized yourself with the Ilo Os 2001 guidelines. Now, let's explore sections of the Indian National Policy on Safety, Health and Environment at the Workplace, which is based on Ilo Os 2001. You have explored the Indian National Policy on Health, Safety and Performance at the Workplace based on the Ilo Os 2001 guidelines. The links between the National Framework for the OSH Management System, or OSH-MS, and its essential elements are illustrated in the following figure. You'll take a look at Section 3 of the document Ilo Os 2001 Guidelines shortly. Here's a detailed look at Section 3. Section 3 of the document Ilo Os 2001 Guidelines gives the details of the various elements of occupational health and safety management system in organizations. Occupational safety and health, including compliance with the OSH requirements pursuant to national laws and regulations, are the responsibility and duty of the employer. The employer should show strong leadership and commitment to OSH activities in the organization and make appropriate arrangements for the establishment of an OSH management system. The system should contain the main elements of policy, organizing, planning and implementation, evaluation and action for improvement as shown in the figure. Click here to view the Section 3 Ilo Os 2001 Guidelines. Click here to download the complete Ilo Os 2001 Guidelines. You've been introduced to the Ilo Os 2001 Guidelines. It's time to take a safe shot. Choose the correct options. Which of the following are the main elements of the OSH management system? You have examined various elements of the Ilo Os 2001 Guidelines. Next, let's explore risk assessment, which is one of the core elements of any OSH management system. Risk assessment is an essential part of the planning stage of any health and safety management system. The likelihood of an effective risk management system is greatly linked to the efficacy of the risk assessment process. Before you start exploring the specific requirements of risk assessment given in the international and national publications, OHSAS 18001 and IS 15656-2006, let's first understand the definitions of the common terms used in the area of risk assessment. Here's a look at the common terms used in the area of risk assessment. You've examined the connotation of the common terms used in the area of risk assessment. Now, let's look at the objectives of risk assessment. The main objective of risk assessment is to determine the measures required by the organization to comply with relevant health and safety legislation and, thereby, reduce the potential level of occupational injuries and ill health. The risk assessment will need to cover all those who may be at risk, such as customers, contractors, and members of the public. In general terms, a risk assessment is a way of evaluating what can affect the health and safety of employees at work. A risk assessment looks at what could go wrong, what is needed to stop it from going wrong, and assesses the effectiveness of any control measure in place. Recommendations for extra control measures can then be made on the basis that they are reasonably practicable. You have been introduced to the objectives of risk assessment. Now, let's examine risk assessors. The responsibility for completing risk assessments will usually rest with the manager or supervisor responsible for the area in which the work is carried out. However, they should receive some form of training in risk assessment techniques before they perform them. In some cases, companies use consultants to undertake the function of risk assessment. This can work, but the consultant is unlikely to have an in-depth knowledge of the specific activities and may only give a snapshot in time of the risks in that particular work area. The risk assessment can be carried out and recorded using a risk assessment form. There is no laid-down format recommended by any standard bodies, and hence the organizations may design their own formats for recording the risk assessments. You have been introduced to the significance of risk assessors. Now, let's examine the composition of a risk assessment team. It is preferable to involve a multifunctional team to conduct risk assessments, since the identification of hazards in various activities require an in-depth knowledge about the work process, work equipment, substances used, and the equipment used. Hence, it is important that the risk assessment team is selected on the basis of its competence to assess risks in the particular areas under examination in the organization. The team leader or manager should have health and safety experience and relevant training in risk assessment. It is sensible to involve the appropriate line manager who has responsibility for the area or activity being assessed as a team member. Other members of the team will be selected on the basis of their experience, their technical and/or design knowledge, and any relevant standards or regulations relating to the activity or process. At least one team member must have communication and report writing skills. It is likely that team members will require some basic training in risk assessment. You've been introduced to risk assessment and risk assessors. It's time to take a safe shot. Choose the correct option. The responsibility for completing risk assessments will usually rest with whom? Well done. The responsibility for completing risk assessment You have been introduced to risk assessment and the responsibility of risk assessors. Now, let's look at the risk assessment methodology. The Indian Standard IS 15656-2006 has recommended various tools for identifying hazards, namely, comparative methods like checklists, audits, hazard indices, preliminary hazard analysis, fundamental methods, what-if analysis, failure mode and effect analysis, hazard and operability study. However, you will explore here below a simpler approach suggested in the INDG 163 5 Steps to Risk Assessment, issued by the Health and Safety Executive, UK. The 5 steps of risk assessment are: identify hazards, decide who might be harmed and how, Evaluate the risks and decide on precautions. Record the findings and implement them. Review the assessment and update if necessary. Let's explore each step in detail. Let's look at the first step of the risk assessment methodology, that is, identification of hazards. Only significant hazards which could result in serious harm to people should be identified. Trivial hazards can be ignored. A tour of the area under consideration. Consultation with the relevant workforce. And a review of the accident, incident, and ill health records will help in the identification of hazards. Following are the other sources of information that can be used while identifying hazards in the workplace. Safety inspection, survey, and audit reports. Job or task analysis reports. Manufacturer's handbooks. Data sheets. Approved codes of practice and other forms of guidance. Here, let's continue with the identification of hazards. It is important that unsafe conditions are not confused with hazards during hazard identification. Unsafe conditions should be rectified as soon as possible after the observation. Examples of unsafe conditions include missing machine guards, faulty warning systems, oil spillage on the workplace floor. Such unsafe condition should not be identified as hazards during the risk assessment process. Hazards will vary from workplace to workplace, but what follows is a brief listing of common hazards that are significant in many workplaces. Slips, trips, and falls, at the same level as well as from heights. Extremes of temperature, indoor and outdoor. Adverse weather conditions, rain, wind, cold, and hot or arid. Natural and artificial lighting. Insufficient or excessive levels, poorly positioned, reflected glare, flickering lights, or stroboscopic effect. Hot or cold surfaces. Burns can occur from contact with both. Falling objects. Fumes, vapors, arcs. From welding, brazing, and soldering operations leading to health hazards. Movement of materials. Falling, collapsing, slipping, spilling, etc. Flammable materials. Gas, solvents, solids, etc., posing the risk of fire and explosion. Waste materials. Sharps, flammable, recyclables, or storage, disposal, and discharge. Vehicles. Loading, unloading, or loads falling, slipping, collapsing, etc. Parking, docking, moving, etc. Here's a look at list of few more common hazards. Access and egress. Blocked fire escapes, access restricted by goods or materials, pedestrians in the proximity of vehicles, etc. Compressed air, burst pipes, noise of operation, misuse or horseplay. Hand tools and handheld power tools. Repetitive strain injury, vibration white finger, noise, eye injury, cuts, strains, and sprains. Ergonomics. Poor design, sharp edges, too low, too high, too heavy, badly positioned, etc. Animals. Kicks, bites, scratches, excretions, crushing, pulling persons over strains and sprains, bolting or stampeding. Overhead or underground services. power cables, water pipes, gas supplies, steam lines, oil supplies, conveyors and chutes, etc. Lone working. Inability to raise alarms, medical emergencies, stress, etc. Exposure to violence or aggression. Food hygiene. Storage of foodstuffs, temperature of refrigeration, segregation of foods for commercial or personal use. A comprehensive checklist of hazards appropriate to the workplace, as suggested above, will help in identifying the hazards without any slip. You've explored workplace hazards. Now, let's examine the second step of risk assessment. That is, who might be harmed in the workplace area. Here's a look at a few more groups that are likely to be exposed to workplace hazards. You have explored the first two steps of the risk assessment methodology. It's time to take a safe shot. Choose the correct option. Missing machine guards is an example of an unsafe condition. Well done. You've explored the first two steps of risk assessment in detail. Now, let's look at the third step of risk assessment, evaluating risk and adequacy of control. At this point, a numerical risk rating may be assigned to the hazard. The significance of the risk is determined by the combination of the probability or likelihood of harm occurring with the consequence or severity of that harm. By assigning a numeric value to the different levels of these two parameters, we can multiply them together to obtain a numeric value for the significance of the risk. This value is known as the risk rating, which is expressed as risk rating equal to probability or likelihood of occurrence multiply consequence or severity of the potential harm. Various scoring systems exist from a 1 to 3 scale, which does not give enough variation to be entirely helpful to those with numbering systems of 1 to 10 or even 1 to 100 as the maximum, which can give a confusing amount of range to the risk rating. The scales used in the examples supplied in risk evaluation given later have been chosen to give sufficient range and clarity of banding. Here's a look at the first stage of risk evaluation. The first stage of the process is to evaluate the risk in probabilistic terms. This is an expression of how reasonably foreseeable it is that harm may occur. The ratings given in the table have been expressed in terms of both probability and likelihood of a hazard causing harm, and so the terminology is interchangeable as matter of preference of the user. The probability of harm occurring should consider the time in terms of duration and the amount of times repetition of exposure that a person is exposed to a hazard. It follows logically that if a person is exposed to a hazard for extended periods several times every day, the probability of harm occurring is considerably greater to him than to a person who is exposed to the same hazard for short periods of time 2 or 3 times per month. You've explored the first stage of risk evaluation. Now, here's a look at the next stage. The next stage is to evaluate the extent of the harm that could occur from exposure to the hazard. These values have been expressed in the table below in terms of injury description, consequent effect, and outcome of that injury in terms of lost time. Any or all of these factors can be used as descriptors and are a matter of preference of the user. You've explored the first two stages of risk evaluation. Now, here's a look at the final stage. Finally, the factors obtained from likelihood and consequence can be multiplied, and a risk rating obtained from the product, which can be expressed in numerical terms and qualitatively in terms of high, medium, or low risk, as shown in the table as risk matrix. You have explored risk evaluation in its entirety. It's time to take a safe shot. Choose the correct option. Consequence is an expression of how reasonably foreseeable it is that harm may occur. Having performed the evaluation, the next part of the process should be to identify the methods of protection that are employed to avoid harm or mitigate the risk to persons or property, and to decide whether they are adequate in controlling the risk or not. The control measures may consist of one or a combination of the types of protection listed below. Here's a look at a few more types of control measures. Control measures need to be assessed for their adequacy and suitability for the level of protection they should or are intended to provide. The following criteria can be applied to assess the efficacy of control measures. Are the control measures adequate, suitable and sufficient, so far as reasonably practicable? Are they effective? Do special provisions need to be made for young people, expectant mothers, ethnic minorities like language, culture and religion, disabled, visually impaired, orally impaired, those with reading difficulties? Have personnel received adequate training in order for them to use, perform or respond to the measures safely? Is refresher or update training required? Are training records held and are they relevant and up to date? Here's a look at a few more criteria for evaluation of control measures. Has everyone been informed of the measures and do they understand them? Are inspections required, and if they are the reports accurate and up to date? Are the control measures clearly documented? Are measures regularly reviewed? Who is responsible for them? What are the emergency procedures in case something goes wrong? Examples: fire, flood warning, bomb alert, gas escape, processes going critical, chemical leaks, machinery faults, electrical shock treatment, first aid for minor accidents, etc. Post-evaluation, if the control measures are not deemed adequate, then recommendations should be made to improve safety measures. This is the point where the following questions are asked. Can the hazard be removed completely? Is a change in working practices or procedures needed to reduce the risk? Is there a better and/or safer way of doing it? There is a preferred method of controlling risk known as the hierarchy of risk control. Risks should be assessed and recommendations made for changes based on the following order of preference. Can it be eliminated altogether? Can it be replaced with something less hazardous? Can the hazard be isolated or separated from those it may harm? Can controls be introduced to the work, or can it be reorganized to reduce the risk? Can personal protective equipment be used? ERICP is a good way to remember the hierarchy of controls. If it is not possible to eliminate the risk altogether, as suggested earlier, the other measures will need to be considered. Here's a look. Here's a look at some more measures which are used to control risk. You have explored the risk assessment methodology. It's time to take a safe shot. Choose the correct option. Gem Paints decides to go with a water-based technology in order to reduce the harmful effects of producing solvent-based paints. Which of the following measures has Gem Paints used to control risk? Till now, you have explored the first 3 steps of risk assessment: identifying hazards, deciding who might be harmed and how, and the third is evaluating the risks and decide on precautions. Now, let's look at the 4th step, that is, recording significant findings. It is important to record your findings and decisions regarding the assessments as well as the means you have decided upon to control them. One reason for this is to assist you in the review of your assessments and controls. When you come to look again at your decisions, it is not always obvious why you made the decision that you did. Also, what is valid now may change in the light of advancing knowledge and technology. Another reason for records is to show that a hazard was identified and the risk was considered, especially if no control was deemed necessary. This could be useful if you have to justify your decisions to an enforcement authority or in court. Here, let's learn more about the recording significant findings. The record of findings provides evidence of conducting a suitable and sufficient risk assessment. It also produces information to create action plans for improvements that need to be made. These can be stored in whatever medium is convenient as long as it is easily retrievable. There is usually a legal or national requirement to record the significant findings only. This should include significant hazards identified in the assessment, existing control measures and the extent to which they control the risks, who may be affected by these risks and any groups that are at particular risk. The results of the recorded findings must be conveyed to staff in a comprehensible and relevant way. Although it is not specified, it is advisable to have the following information recorded on a risk assessment to ensure traceability. The area or work activity being assessed, date of assessment and the assessor's name, what the hazards are, who is exposed, staff, contractors, visitors. Risk rating, which is numerical and high, medium, low. What control measures are in place and any comments on their adequacy. Any recommendations for changes. When the action is required by. Who is responsible for the action? Date when the action is completed. Further action or next review. You have been introduced to 4 steps of the risk assessment methodology. Review assessment is the final step. Here's a look. Performing a risk assessment and filing it away is not the end of the process. It is ongoing and needs to be reviewed and updated regularly. The process of review will ensure that any changes to control measures that have been specified can be checked for progress and reassessed for their effectiveness. Subsequent risk assessments need not be as detailed as long as there have been no significant changes in working practices or procedures since the last assessment. Reviews should be carried out after an agreed set period, normally stated on the risk assessment form. Following a change of working practices. After the delivery or commissioning of new plant or equipment. After any adverse event, accident, equipment failure, etc. after it is deemed that the original risk assessment is no longer valid. Here, let's know more about the reasons for review. It is important to monitor systems. This is also true with these safety measures. Situations change, methods of use change, technology and current knowledge move on, and so must your controls. A side effect of improving knowledge is that what is considered a low risk today may not be so tomorrow. An example of this is hardwood dust. Once considered to be little more than nuisance dust, now recognized as a carcinogen or a substance which causes cancer. The review of the assessments needs to be regular, but it does not have to be an onerous or major task, nor does its frequency need to be any more than annual, unless there are changes such as an alteration in the process used or the introduction of new equipment or procedures. All that is necessary is to look at the decisions and reasons for the controls you have chosen and decide whether they are still valid. You must be able to demonstrate that you have carried out the review by recording the fact, most usually by inserting the current date on the assessment record or form. Remember, the aim is to prevent someone being hurt or property being damaged. You have explored all 5 steps on the risk assessment methodology. It's time to take a safe shot. Choose the correct option. Shared workplace staff, delivery vehicles, members of the public, and the emergency services shall be considered while deciding the people who are likely to be affected by the hazards. Well done. Here's a look at the concepts that have been covered. British Standard OHSAS 18001-2007. The OHSAS standard is based on the methodology known as Plan, Do, Check, Act, or PDCA, and promotes the process approach. Section 4 of the standard discusses the details of the individual elements that include general requirements, policy, planning, implementation, checking, and review. ISO 14001-2004. This standard is identical to British Standard OHSAS 18001-2007, with the exception of 4.3.1, which deals with risk assessment in the former and environmental aspects in the latter. ILO OSH 2001 Guidelines. ILO OSH 2001 Guidelines for OHS management systems have been developed by the ILO according to internationally agreed principles defined by ILO's tripartite constituents. Here's a look at the concepts that have been covered. Principles and practice of risk assessment. Risk assessment is an essential part of the planning stage of any health and safety management system. The likelihood of an effective risk management system is greatly linked to the efficacy of the risk assessment process. The main objective of risk assessment is to determine the measures required by the organization to comply with relevant health and safety legislation and, thereby, reduce the potential level of occupational injuries and